Hydrogen iodide is added in a evacuated reaction vessel. The vessel is sealed and warmed. A decomposition reaction occurs. Hydrogen and iodine are formed. Some hydrogen iodide remains. When the equilibrium is established, the total pressure is 1.2 × 10⁵ pascals and the partial pressure of hydrogen is 4 × 10⁵ pascals. Hydrogen iodide, hydrogen and iodine are all gaseous under the conditions used. What is the value of Kp? That means constant pressure for the reaction at the temperature assuming that the decomposition reaction is forward. So for this reaction we have hydrogen iodide reacts to form hydrogen and iodine. Initially we take hydrogen and iodide as X, hydrogen and iodine as 0. So we have given that the partial pressure of hydrogen iodide, no, this is the partial pressure of hydrogen, that is H2. So we have given the partial pressure of hydrogen and we have given the total pressure. So we know that the partial pressure is equal to mole fraction into total pressure. So the mole fraction would be partial pressure by total pressure, that is 1/30. So we know that the mole fraction is 1/30. That means the mole fraction of hydrogen is 1/30. So the mole fraction of iodine is also 1/30 since they are of the same mole. And the mole fraction of hydrogen iodide would be, since we can see that the total mole is 30 and each of these hydrogen and iodine are of 1 mole, so it would be 28/30. So constant pressure, that is Kp or equilibrium pressure, is equal to partial pressure of hydrogen into partial pressure of iodine by partial pressure of hydrogen iodide square, since there is 2, and the partial pressure we represent this as mole fraction into total pressure. Partial pressure is the mole fraction into total pressure and we take total pressure as PO, and after writing this equation we can see that PO cancels each other out. So the final value of Kp comes to 1.28 × 10⁻³ So the answer would be B.